Welcome to the video. Ernest Rutherford, father of nuclear physics. Ernest Rutherford was born on August 30th, 1871 in Brightwater, New Zealand. He was the fourth of 12 children. He was born in colonial New Zealand. It wasn't even a country yet, and they lived quite a ways from the nearest town. They lived on a farm. In 1886, he won a scholarship to attend Nelson Collegiate School, a private secondary school where he excelled in math and science. 1890, he wins a scholarship to attend the Canterbury College in Christchurch, New Zealand. The college is one of the 4 campuses of the University of New Zealand. It was very small. It only had 7 professors at that time. 1892, 1893, and 1894. He continues going to school there. He gets another scholarship and gets a bachelor's degree, and then he gets a master's degree. And then he goes back again to compete in another scholarship that will take him to Cambridge University in England. He has to be enrolled in school so he can compete for that scholarship. So in 1895, he's awarded a scholarship to study at Cambridge University in England for postgraduate education. He studies at the Cavendish Laboratory, which is part of Cambridge, under the professor J.J. Thomson, who is at that time one of the leading experts on electromagnetism in Europe. And Rutherford first starts out working on his radio wave transmitter and detector that he had been working on. And at one point he had one of the longest ranges for a radio detector at that time, until Marconi passed him up and built the modern radio. So he works there, and then he gets involved in the study of radioactivity, because that had just been discovered a few years before by Henry Becquerel, and that had swept kind of the physics community of people really interested in radioactivity. And then the X-ray came along, and that got everybody pretty interested in those two topics. So in 1898, after graduating from Cambridge, he becomes a physics professor at McGill University in Montreal, Canada, and he begins to study the newly discovered radioactivity. And there he develops the concept of half-life for radioactive material. Each type of radioactive material decays at a certain rate, and the way they classify it is by X number of seconds, minutes, years, or months, whatever it takes for half the material to disintegrate, then that becomes the definition of the half-life. He also coins the term alpha and beta radiation. That was 2 types of radiation that was emitted by radioactive material. They used a lot of radium that the Curies had refined. And he marries Mary Georgina Newton from New Zealand, and they have one daughter, Elaine. This was a young woman he had met when he lived back in New Zealand, and they had maintained a long-distance relationship, and finally they got married. In 1902 to 1903, he works with the chemist Frederick Soddy to develop the transformation theory, or disintegration theory, as an explanation for radioactivity. This is where one type of radioactive material disintegrates and emits radiation and turns into another type of material, or an isotope. And they didn't fully develop that then, but Soddy went on to develop the concept of the isotope, and that's what he's famous for. 1907, he moves to England, become a physics professor at Victoria University of Manchester. He wanted to go back to England because Europe was the scientific center of the universe at that time, and he was back in Montreal, and there was not a lot of people he could communicate with directly involved in physics, and he wanted to be where the action was, so that was back in England. And there he works with the German physicist Hans Geiger, and they develop a counter for ionized particles. And later Geiger works with a man named Mueller, and they perfect the Geiger-Mueller tube, and that's what we use today to detect radioactive radiation. In 1908, Rutherford is awarded the Nobel Prize in Chemistry for his investigations into the disintegration of the elements and the chemistry of radioactive substances. So this really put him on the map in the world of science, winning a Nobel Prize. That was a big deal. It still is a big deal. In 1909, with the help of Hans Geiger and Edward Marsden, he conducts the gold foil scattering experiment that shows the nuclear nature of the atom. His mentor, J.J. Thomson, had come up with what's called the Plum Pudding model of the atom, but Rutherford wanted to test that, and he did this gold foil experiment where they shot alpha particles at different types of metal films, and by looking at where the alpha particles were scattered, he could determine that the Plum Pudding model was not really the correct model of the atom. So he develops in 1911 what's called the Rutherford Model of the atom, and it's close to what we have today. It consists of a positively charged nucleus, and it has the electrons, which were at that time called corpuscles. That's what J.J. Thomson had discovered. They orbited the positively charged nucleus. They didn't really know much about the nucleus at that time, but that was a more close model of what we have today. In 1919, J.J. Thomson retires from the Cavendish Laboratory at Cambridge. He was the director. He'd been there for many years, and Rutherford is named his successor. So he moves from the Victoria University of Manchester over to Cambridge, where he will spend out the rest of his career at the Cavendish Laboratory. That became one of the better laboratories in the world at that time. One of the things he does, he simulates a nuclear reaction in a stable element, finds that nitrogen and other light elements ejects a proton when hit with an alpha particle. So he does a lot of radiation experiments. And this Danish physicist comes to work there at the laboratory for a while. His name is Niels Bohr, and he's a theoretician. And so Bohr refined the Rutherford model of the atom to make it more usable to model the different chemical and physical properties of an actual atom. And then Rutherford theorizes a neutron, which hadn't been discovered yet, in part of the nucleus of the atom. And so in 1932, one of Rutherford's associates there at the Cavendish, James Chadwick, discovers the neutron through a series of experiments. And so from there they learn that the nucleus is basically composed of protons and neutrons. So that's the modern theory of the atom, or very close to it anyway. And in 1937, Rutherford dies there in Cambridge. He's actually helping his wife trim a tree out in their garden, and he falls, and it ruptures an old hernia, and it becomes strangulated. And he went to the doctor, and they tried to fix it, but they could not. He ended up dying a few days later, and he was buried in Westminster Abbey next to Isaac Newton and some of the other dignitaries of science that were buried there. So if you'd like to know more about Ernest Rutherford and some of his accomplishments, I've listed some additional information at the description of this video, so take a look at that if you want to find out some more information. I hope you liked this video. If you did, please give it a thumbs up, subscribe to my channel, and thank you for watching.